My name is Alex, and today I'll be talking about the shared decentralized sequencing for rollups. Originally, the title of the talk was I was about to talk about the actual consensus and the DA solution that we had. But after talking to some people, I realized that maybe it's easier, or it's better to do like a one-on-one and to just bring everyone on the same page on why do we need shared sequencings and why we're doing what we're doing. The agenda will roughly be like why decentralized, why we need a share sequencers, and roughly how we do it. And finally, I will do a demo of our latest testnet. Okay, so if we look at the rollups today, or at least the idea is that we want to horizontally scale Ethereum. So instead of doing a lot of heavy computations on layer one and processing a bunch of transactions, we offload them to different layers. Who are doing so? You think of them as you shard the amount of execution that's needed into these different rollups, and what the layer one, which is somewhat resource bounded and resources limited, will only have to do like cheap verification. Let it be validity proof in the case of ZK rollups or fraud proof in the case of optimistic rollups. However, the current status or the status quo is that today's rollup servers, or all of the rollups in productions are running right now, has a very centralized servers, and these servers controls a lot of things. First of all, it centralizes all the decisions on what transactions to include and in what order. So the first point of what transaction to include, that's a potential point for censorship. And the second point of what order do you include, that also gives them the power to monopolize the MEV that exists in the block. And of course, they're not doing it for, my personal opinion is that, first of all, there aren't that many traffic on rollup just yet. If you look at Polygon, I think their throughput was like 0.5 transaction per second. So there aren't that many transactions to be exploited. The second one is that they're altruistic at the beginning, of course, because they want to attract users. Don't attack me on those opinions. A counter argument for saying that decentralized is that they do have escape hatch on the layer one. If you observe anything, the idea of escape hatch is that if you observe any misbehaving behavior or like censorship behavior of these centralized operators, right? What you can do, you can bring your transactions and go to the layer one, and the layer one will force inclusion, right? So even if the operator is not responsive or censoring your transaction, you can still find a way to force your transaction into the block. But the problem is that escape hatch is also very limited in the sense that it cannot deal with mass exit. Imagine that your operators goes down or just constantly censor you just because it doesn't like you. There's no way that you can resort to the adjudicator on layer one and say, he's censoring me. There's no evidence for you to do that. And plus, you cannot slash anything that's related to liveness. So it's hard to prove that some liveness misbehaving of the operators. The other point is slightly subtle. It's on the price gouging. What that means is that if let's say you resorting, because like the escape hatch is sort of like a last resort. It should be a last resort because it's expensive. It incurs costs, on-chain gas costs. So if taking your transaction to layer one and force inclusion takes you, let's say, at least 21K thousand gas, 21K gas or whatever, like $10, then what the rollup operators could do, if it's rational, is I will charge you $9.9 for every transaction, regardless how big or small it is, because it will still be better for you to just send it to me. Even if I'm, let you wait in the mempool for a very long time, it's still cheaper for you to just give it to me. So that's what price gouging means. So I can have monopolistic price settings, if that makes sense, right? If things are centralized. So a solution to this is what Justin Drake coined as a base rollup. Well, the idea has been floating around for a very long time, but he just gave the name of base rollup. What that means, the essential idea is trying to separate the ordering from the execution. So instead of the user sending transactions to the centralized rollup who will actually bundle them up into the block, what I can do is I ask the users to directly send the transactions to the layer one validators who are decentralized, and have much better censorship resistance. And the layer one will only do the ordering and also the DA, making sure the data is there, but it will not do the execution because the whole point of rollup is trying to horizontally scale by pushing the execution off to have more powerful nodes off chain. So the execution will still be online, but the proof they will still post those proofs on the layer one. So that's what base rollup is. The problem, well, it's not really a problem, but the characteristic of this approach is that your throughput and let it be the consensus throughput or your DA throughput is inherently bottlenecked by the layer one, whatever layer one consensus provides, right? And also the confirmation, the finality, how long does it take for you to finalize the transaction is the same as what layer one provides, right? So that's the kind of the pros and cons of base rollups. So that brings us to why do we need a specialized sequencing layer and why that is somewhat of promising alternatives is that I usually think of ourselves as a layer in between the layer one and the rollups themselves, and we call it like layer 1.5. You can think of it as we are doing like sequencing as a service. So what we do is we also offer the ordering and also make sure that DA is there, the execution is still at the rollup level, and the layer one still just do the cheap verification. So I think that's clear enough. So the transaction will be sent to the decentralized sequencer at our layer. Okay, and I just want to point out that there are people, if you are very curious about what rollup definition is, as Dan Kurt himself is, then anything that does not post your DA or relies your DA on layer one or post your data to layer one is not considered as rollup. Well, in our case, we understand the different opinions, so we give you the option if you want to additionally post your data to layer one. So in our previous testnet with Polygon ZK-VM, we only ensure the DA at our own layer. If that does not satisfy you and you want further guarantees, you can further post your data to layer one if you want, which is our latest testnet does support that. Okay, so let's just summarize the reasons for like separating the sequencing layer. One is modularity. The other, I think, is very, very important, right? Is that we can make a different design choices and different design trade-off from the layer one consensus. Since now we have our own sequence layers, we can choose a different consensus protocol. What that means is that the Ethereum consensus is a availability favoring consensus. It's a longest chain proof of stake that supports dynamic availability. What that means is that the nodes can go online and offline all the time, but the safety wouldn't be violated. Same thing for Nakamoto consensus. But because of the cap theorem and the derivative of the cap theorem, you cannot have fast finalities and dynamic availability at the same time. So you kind of have to choose your camp, right? So at our level, because we have a dedicated sequence layer, we can choose something that's complementary to what layer one is offering. Layer one, Ethereum is offering dynamic availability, which is great because that's liveness is always there. But then for a lot of applications, you want fast finality as well. So we choose the BFT family of consensus where you can have actual fast finalities. So a point there is that many people, or at least most of the rollups nowadays, right? They just say, whenever I see the data being posted on layer one, the rollup block posted on layer one, then I will consider it as final. But the thing is, 12 seconds is just the block time. It's not the time for you to finalize for the Ethereum block to be finalized. In order for that finale, the Casper finale gadget to take, it needs to take like 15 minutes. Right, so if you want finalizing transactions, that's not, Ethereum layer one consensus is just not the way to go. So the third pros is that we can have like fast pre-confirmation. If you receive a block from our sequencing layer, and if you are decentralized enough, if our consensus is secure enough, you can consider that as already finalized. It depends. So kind of choose your own settlement layer thing. If you trust us enough, then that's already like very finalized, right? Okay, so apart from that, there's another caveat I want to mention, which is incentive compatibility. So what it means, even in one of the earliest academic papers on MEV, the Flashpoint 2.0, in the abstract, the author has already cautioned us on the possibility of a systemic risk that MEV posted on the consensus. So what that means is that a lot of the proof of stake depends on like slashing and or like if you are misbehaving in a consensus protocol, someone will present the evidence and you will get slashed. However, the kind of payoff matrix for these validators to act who act rationally will be saying, judging my upside of cheating and judging how much I will be slashed if I cheat, which one do I choose? Now, if the rewards, the upside is just the block rewards or the transaction fees, might be not that much. But now, if adding the MEV profits it might be profitable or reasonable for you to actually cheat and get slashed. It's okay because I can profit. So I can reorg the chain or double vote it if I can make so much money from the MEV extraction. The same thing would apply to the rollup world, right? Imagining that Arbitrum, Optimism, and zkSync, StarkNet, they grow so big that the MEV on their chain will be destabilizing the consensus on layer 1 because they're all like layer 2 to Ethereum. Now people have much more incentive to reorg Ethereum, not because they can make profit from Ethereum or they don't like Ethereum, just because they want to make more EVM extractions from these rollups. So we need to make sure, like the centralized rollup operators just might fall into this caveats. So we need, the conclusion is we need economic incentive alignments. And the way we do it is sort of through restaking through protocols like eigenlayers. What that means is that even if we think of the sequencing layer as like a separate, logically separate, but they could be physically the same nodes. So the Ethereum validators will get a percentage of the MEV or whatever the value creation from the layer 2 world. So it won't be like such lopsided or unbalanced. Okay, another misconceptions. Well, at least Ian Millers and other people are posting on Twitter is that should we think of just the shared signature just another blockchain, because it seems that we're doing consensus and everything. It just sounds like a blockchain. And I won't go into detail, but roughly sequencing is actually a relaxed problem or easier problem than the actual full-blown state machine replication, which is what a blockchain or consensus is. Right. So Kartik, which is one of our advisor, has a very good talk at SBC this year, where he talked about the differences between the key requirements between the differences between SMR and sequencing. Originally in SMR, you would have broadcast, execution, and consensus. For us, we don't do the execution. Again, think of us as sequencing as a service. We're only doing sequencing. We're not doing execution. Execution is still at the rollup layer. Oops. All right. And also, we don't need full data broadcast. We don't need the atomic broadcast. What we need is a relaxed requirements called data availability. Just ensure that the data is available for people who needed it. So each node actually needs to process much smaller chunks. So these are the two that we need. So this answer the questions of people asking, why don't we just use, dropping Tendermint consensus? The code is there. Why don't we just use Tendermint consensus? I guess the answer to that is because sequencing is a slightly different problem, so you have much more room for optimization if you realize the differences between, the problem formulation. So, you can have a lot more improvements and better protocol for sequencing. Okay. So that's the decentralization part. The next part is shared. Why do we need shared? I want to briefly go through the 3 advantages, and then we'll go to demo because these slides are somewhat boring. The advantages are easier bridging, lower risk, and easier cross-rollup building. And I want to emphasize that what shared sequencing provides is atomic inclusion, okay, but not atomic execution, because we don't do execution. There's no way we can guarantee atomic execution. But in an environment where if you consider the whole system of the whatever, outside the layer 1, it's already a heterogeneous execution environment. It's no longer like the homogeneous execution environment in the layer 1 anymore. Atomic inclusion, I would argue, is as good as we can get. Okay? So very quickly, what do you mean by easier bridging? So let's consider the simple case of bridging assets. Usually how that works is that you have 2 chain or 2 rollups. You lock the assets on one chain, and then you receive some messages from some evidence, and you can unlock or mint a representation of that same token on a different chain. So let's compare the 2 scenario. Imagine you have a siloed sequencers, which means that every rollups have their own sequencers. How would that work is that the rollup B will have to verify the inclusion of the locked transactions on rollup A, and also the consensus of the rollup A. So you have to run a light client essentially in rollup B, so that's constantly receiving, like, let's say, the block headers of rollup A, and you have to constantly verifying that the consensus, or for example, the signatures are assigned correctly, depending on whatever the validity of the consensus means. And also you can see it's usually like 2 steps, right? It's somewhat asynchronous, and if you want to do two-way bridging, you sort of have to do this two-way things. So that's what I mean by like one way. I think it has a direction when it comes to like this bridging. And then consider share sequencing, where the mint and the lock transaction can be in the same transaction bundle because we are receiving it from multiple rollups. So the rollup B, since it's already, you already have to verify the block that he received because this is the block that you originally have to receive. So the only additional thing that you need to do is just verify that both transactions, the mint and the lock, is in the same transaction block, which is trivial. So that's somewhat much more synchronous. It doesn't really make a distinction between whether you are bridging from A to B or from B to A. It doesn't really matter from this perspective. So that's what I mean by two-way. It's probably bad choice of word. The next thing is lower security risk. So imagine on rollup A where you lock the asset in order to mint more the equivalent amount of asset on rollup B. If there's a reorg on rollup A, that means that you can have double holding of the locked funds, right? So I think that's easy enough. But if you have a shared finality layer, like the shared sequencing layer, first of all, it's assume it's decentralized enough and secure enough. It's hard for you to reverse the finality because we're choosing a BFT family, which is like finality, like finalizing family of consensus. So even in a rare case, it does get violated. That the reorg does happen. The lock and the mint who appear in the same block will be reverted anyway. So there's atomicity in there. So that's what I mean by lower security risk of bridging. The third point is on cross-rollup buildings. So there has been a lot of talks on cross-domain EVMs. What that means is that the EVM opportunity is coming from cross different chains. So sorry for the low resolution of this image. Imagine you want to do like a cross-rollup flash loan where you take a loan on one chain, one rollup, do some swaps on the second one, and then finally return the money on the third one, something like that, right? So in a silo sequencer case, imagine how you have to do it. First of all, usually a lot of these rollups will support PBS, right? So you being the builders who are trying to build this cross-rollup transactions, right? The cross-rollup flash loans. Flash loan transactions, you will have to win the auction on all the chains that you're participating with, and simultaneously. That's a very high bar to hit. Now you're saying, okay, well, a natural solution to this is that I cannot guarantee that I always win the auctions every time. So why don't I just try to be the proposer on both of all of these chains so that I can include my own blocks, right? I don't have to win over other blocks. But the problem is, imagine you have 10% of being selected as the leader, or being 10% of being the one who proposed the block in one of the chain. Then, and also you have 10% on another one. The percentage or the likelihood for you to be the leader on both chain is like quadratically lower, right? It's like one in 100. So that means that you need higher stake. And that kind of push people. If the cross-domain MEV is so high, it will push people to have much more stake on all of the chains, and that's kind of a centralization risk. And this point is actually pointed out by the Flashpoint team, the Flashbots team, which is something kind of eye-opening for me. So in the case of a shared sequencers, you only have to win it once because we have one shared sequencing. So I think everything is much easier, and also the builders now, it's much more predictable for him to know that my block that includes these cross-rollup transactions is going to get included, so that the builders can give an economic guarantee to the users saying that I make sure that your cross-rollup flash loan is gonna get included. I can give you the promise. If not, then you can slash me. In the previous case, because it's so unpredictable, there's no way. It's really hard for you to say that I can guarantee you that I'm going to win the auctions on all the chains simultaneously in a certain block. That usually I don't think the builders will be I think they will be very hesitant to agree or make that promise. So with that, let me just put everything together before the demo. So the user send the transactions to different rollups, whatever rollups you want, and then it will go through some PBS. The relayer and searchers and builders will build a block that could include like rollup transactions. It will go through our DA. Our DA will make sure the data is there, and then the consensus will finalize on the ordering of these transactions. And once that is done, the stream of block that's already finalized, that's the fast pre-confirmation, will go back to the layer 2, and then the block will be sent to on-chain contracts that keeping track of like what's the current state commitments. And the layer 2 will later on, once they have received the latest block, they will start producing the proof, let it be a validity proof, or if they see something is wrong, then they can provide a fraud proof. Okay, so now let me do the finger cross. Let me do the demo on Optimism and one of our latest testnet called Cordado. All right. All right, can you see? Okay. All right. Let me. Okay, so on the left, what I'm doing is I'm deploying the layer 1, and also I'm deploying our sequencer network. So and also the rollup. So we're first of all deploying like a local geth, and then that's the layer 1, and then I'm deploying our sequencing network, which is our Espresso sequencer, and then lastly I'm deploying a Optimism rollup. Okay, that's connected, and we configure in a way that the Optimism, the OP code, the OP node will use us as the sequencer. Okay, so it will take a while. Okay, wait, what? Oh, I don't have internet connection. That's bad. Ah, shoot. Guests. Does it need any password? Ah, come on. Ah, come on. Sure. Yeah, sorry about that. But anyhow, it's supposed to be a very slick demo. So you can approach me afterwards. And just recently we're going to like a formal partnership with Offchain to bring sequencing the option of using us as their sequencing layer to Arbitrum. And approach us if you want. And thank you. Oh, sure.
I have a question.
Yeah, go ahead.
So, like you said, the problem with sending your transactions directly to L1 is that we're bottlenecked by the throughput is bottlenecked by L1. But if like your sequencer layer and your L1 are the same physical nodes, then how are you getting by that problem?
No, because we're running our own consensus, right?
You're running your own consensus, and because like the task of sequencing is easier, so the consensus is like
it's faster, right? Exactly. And also, yeah, I think it depends on like the DA layer. Our DA throughput is much higher because it's easier. Okay, so why our throughput is higher in terms of the consensus? There are a few, right? One is we move like full data broadcast out of the critical path. So you don't need everyone to get the data in order to agree on the consensus, right? So data dissemination is separated from the consensus. That was the idea of Bullshark and the DAG protocol. And that's also something that we adopt as well. right? So when you want to reach consensus, you know there's less amount of work you need to do. Yeah. So the throughput will be higher. Is that your question? Yeah.
Are there other questions?
And do you remind me of how the sequences are decentralized and incentivized? One. And two, can you explain a bit more how Eigenlayer interacts between layer 1.5 and layer 1?
Yeah, right. So, okay, let me answer the second question first. Eigenlayer, so how they do is, okay, in order for you to register as a validators in our sequencing layer, you can go through the Eigenlayer. So what it means that if you are Ethereum validators today, you have to restake on the AVS, they call AVS or the Ethereum Eigenlayers restaking platforms, and you opt in to provide the service, the sequencing service for us, right? So that also open you up to possible slashing if you're misbehaving in the Espresso sequencing layer. So that's how we interact with Eigenlayers. But of course, we also want people who are not just Ethereum validators. So we also open up to native validators as well. So your first question is.
Oh yeah, how it's incentivized, but I guess the Eigenlayer product thing about too.
Yeah, well, they will be fee charged for the work of sequencing, right? So yeah, there will be transaction fee, and also just like any PBS, like as a proposer or the leader in our consensus protocol, you will be receiving. You will be like sort of running like auctions among all the builders who are building the blocks who offer you like a fee, right? So that's some incentive for the leader or the proposer to accept that and then include that block into include that bundle into the block. Yeah.
Awesome. Thank you.
Thank you. Yeah. Thanks.
Thank you, Alex.